Hello everyone, I'm Nimrod. Over the next 30 minutes or so, I'd love to talk to you about how you can utilize open source tools to automate and simplify AWS's IAM. So a few words about me. I'm currently a solution architect at Bridgecrew, the security platform for infrastructure engineers, but that's for another talk. I've been working with AWS for a few years now, and I found Terraform to be extremely useful in really many use cases. I'm also involved with a few open source projects around AWS and Terraform security, which I either co-maintain or continuously contribute to. My newest one is called AIRIAM, which by the end of this talk, I hope you'll also be a fan of. But let's take it slowly. Let's start out with talking about IAM. So AWS's Identity and Access Management Service, also known as IAM, is in simpler terms the service which decides who can access what in the account. That includes users, employees, servers, everything. When I look at IAM, I find it to be very similar like a road system. It's meant to give people access to stuff. And when you start it in the cloud, usually your IAM setup is very simple, right? You set up maybe a few users for IAM users for your employees, and maybe a few roles for the servers. Like usually you start out by setting up an EC2 with a public IP, so it will serve some requests from your app. Now, the biggest advantage the cloud gives us is the ability to grow and scale. Right? So hopefully as the demand grows for your application, your single EC2 instance just won't be able to serve all the incoming requests. So you would, for example, put an auto-scaling group in place, put a load balancer in front of the auto-scaling group, maybe use an RDS database to store data between all the different instances. And suddenly your single server, which serves this very simple set of requests, becomes a complete architecture. And as you add more endpoints, more resources, more services, AWS services, you'll over time won't be able to recognize your own IAM setup, right? Stuff you created, like the users and the roles, will be mixed up with entities created by other employees in your company, or even implicitly by AWS. No one goes through them and deletes them once they're done. No one makes sure that their privileges are least privilege, and stuff just gets stuck in IAM. If you migrated any database technologies, well, you might have had different privileges before and now you need new privileges, but that doesn't mean the old privileges were removed. Since IAM is intertwined in every one of the AWS services and resources that you deployed, it's really hard to stay on top of it. Now, coming at it from a security perspective, there's really just one question IAM should answer. And that's this simple question. However, it is hard to answer. So let's try to break it down and see what it holds. So the first question I would ask is, who has admin access to the account, right? So naturally, I would go to the administrator access policy and see who has that policy attached. You can see in this example, we have a group and two roles who have this policy attached. So the two roles, I know who they are, I can check them or whatever. The group, I'm not so sure. So the next thing I would do was click on the group. And now I see there are 11 users who are members of this group. And so they all are admins in the account. So that's all the account admins, right? Well, almost. You see, this policy is attached to some role. It's related to ECS, as the name suggests. And you can see that it allows all actions on all resources. That's an admin, right? Except it doesn't show anywhere in the account. I need to go through all the policies to find these policies and fix them. So the example that we just saw actually exposed two different recurring issues in IAM. One is that IAM is easily bypassed, right? You just attach a policy or attach the user to a group or maybe replace a string with a star and suddenly your role works. It doesn't mean it has the access it needs. It just means it has more than what it had before. The second thing is that IAM can have very complex relationships. For example, this user, right? Every IAM user can have either a policy attached to it or an inline policy put on it. But it is best practice to use a group to manage user permissions. So the group has those policies and the user is attached to the relevant groups. But what about a role that can be assumed by that user, or a role that can be assumed by another role? It's really hard to understand what the privilege boundaries are in an account just because of the complex relationships IAM gives you. Another issue that we've ran into multiple times is the difficulty of enforcing access patterns over time. Let's say you use IAM users for your employees. You can make sure everybody today has MFA access, right? You just go to each person who doesn't have MFA and tell them enable MFA until he does it. But what happens when new employees are onboarded? No one makes sure that they have MFA set. You'll need to actively go and make sure that they set up MFA. That means you're constantly polling the status of the account. And then another issue is the fact that it's hard to trace and verify usage. Let's say I gave someone permissions. Does he actually need all the permissions I gave him? Does he actually use them? And what happens if he moved team or we changed the service that is used? He will then have access to the new service, but who makes sure that the old service, he loses access to it? Again, let's see a simple example of it. You'll see this is the 11 admins from the admin group we saw before. And if we'll look closer, we'll see that 10 of the 11 have access keys which are older than 90 days. So best practice by multiple benchmarks like CIS and SOC 2 says that access key age should be up to 90 days and then it should be rotated if it is in use. So as you see, we only have one user who's compliant to that requirement, but that's not it. We also have 4 users who have passwords, pretty old passwords, and no MFA. All of these users pose brute force risk to account takeover, because if someone guesses their password, they have admin access to the account. And then the last thing I would like to show you is that 2 of these admins actually had no use in the last 200 days, or over 200 days. So I really don't see any reason to keep those users and their active static credentials for any reason. Okay, so we saw 4 different problems. They're pretty acute. How do we fix them? How do we go about handling them? So the first thing I wanted to show you was the manual flow that we created to help us fix it. It starts out by enriching the entities, I call it. You go through all your IAM, you make a list of all the entities, the users, the roles, the groups, and you just list which ones are used and what they're using and when. That can be used either through CloudTrail data or Access Advisor data that's available in AWS. And once you've done that, the first question is easy, right? Whether the entity is in use or not. If it's not, well, the action is simple. Let's talk about what it is if it is in use. So if it is in use, we need to talk about which privileges are actually needed and create a baseline based on usage. So this means that following this flow, nothing should break, as all privileges that are in use will be maintained. But this gives you an easier ability to actually revoke permissions that shouldn't be used and identify problematic places in your application. The third thing is to create a recommendation. Great, so I have a list of privileges. Now I'm making the policies I want to put on, or maybe creating the groups that I want to give to support all the users I have in the account. And then finally, I need to get approval from the relevant stakeholders. We don't want to surprise anyone by the changes that we do to the account. And finally, just implement the changes. How long would that take you? Well, from my experience, going through all the entities in the account, that really depends on the number of entities, but it could take you even a whole hour. Creating the permissions baseline is even more tedious, as you have to go entity, policy, and just see exactly what it is being used for. Maybe reuse specific policies, maybe create new policies and split up existing overprivileged policies. Then the third one, to create the actual recommendation. That depends on you, but if you did the prior step really well, this shouldn't take too long. It's just creating a JSON from the periods that should be given to each entity. And then the stage of getting approval from the relevant stakeholders, that could take a long time. It depends on your organization. Gladly, I'm really happy to say that in Bridgecrew it took us a few days, but it could take you even more than a month. And then the last thing would be to actually implement the changes. If you use either the CLI or AWS console, you'll find that it's very tedious. You have to select the entity and delete it, or if you're using the CLI, you have to detach the policies from the role or from the user before you remove them. So this is becoming really, really hard. And I don't know about you, but when I did this for the third time, I understood there's no reason to do this manually. We can automate at least 90% of this process and make sure that it really streamlines the entire process and makes it enables us to run it once every maybe week or 2 weeks or 1 month without the heavy burden of the time spent on it. So I'd like to introduce to you a new open source tool. It's called AIRIAM. It's completely free. It's open sourced. You can go visit this link. We love contributions, so feel free to contribute if you see anything that's worthwhile. Feel free to try it out. It's a simple pip install. Really, some of Bridgecrew's customers are already using it, so feel free to try it out. Before we dive into details and a demo, let's talk about what we wanted to achieve with this tool. So the first thing is to identify unused entities. What does unused entities mean? It means users that are unused. It means roles that are unused, but it also means policies that are unattached. It means the policy exists, but no one is using it, and it's a custom policy. It's not AWS managed. Groups that have no members or have no policies, there really is no reason to have that group. And it also, and I think that's the most important part, it identifies policies that are attached to users, groups, or roles, but aren't actually being used using the Access Advisor data and the data from AWS. And so it actually does some right sizing. It removes policies that are no longer in use. Second thing is to detect drifts and enable rollback. We want to be able to, over time, identify if a new user was created, if a policy was modified, if a bad policy was created. And we also want to enable rollback. Let's say I changed something and I deployed it. Well, it broke something. I want to go back. It's really, really easy. It would be really cool if I could just go back to version control my IAM, basically, and just go back to a previous version, deploy it, and it works. We wanted to be able to handle scales of over 1,000 entities. When we talk about user memberships and policy attachments, we reached the 1,000 threshold very easily. I'm hoping for you guys, if you use it on a real account, you'll probably see around 1,500 entities. And then we want to support stakeholder approval, right? We want to be able to talk about the modifications we want to do, and we don't want to do it over Google Sheets or Word documents that are very time-consuming to create. And then the last thing would be to reduce the time to right size. The flow I showed you from before, it takes really long. We want to really make it quick and simple. So AIRIAM, this is a very simple component diagram. It queries data from AWS IAM APIs and AWS Access Advisor APIs, and it outputs the data. It can output it to the CLI, as you'll see in a minute. But what I think would be the most useful was if you use it to create a Terraform code using AIRIAM, and that can support everything that we talked about. So let's start seeing the tool. The first command is called find unused, And the other two commands that we'll see soon will be built on top of it. This command scans your existing IAM configurations in your account and enriches the entities and marks those that are unused as unused. Let's see it in action. So I'll open my terminal and I'll hit AIRIAM find unused. I'm in a new folder that hopefully doesn't have much. If you'll see this, so I already ran it beforehand, so you'll see it says we're using local data. In your case, it might take a few moments as it queries all the relevant APIs to get all the data that it needs. It then just starts outputting all the unused stuff that it found. For example, we have 4 users that were unused, that are unused in the account, the misconfigured admin user, the unused admin user, another one, and an unused user. We don't have unused access keys or console logins, which are cool. I would say that these are not redundant to the unused users. So these users might have unused access keys, but since they are by themselves unused, there's no reason in listing them again. We have 3 unused roles, do nothing function, the organization account access role, and the serverless architecture admin. We also have 2 groups that are redundant, one with no members, another one with no policies, etc., etc. And as I said, the policy attachment that is unused, you will see this S3 user has the STS policy attached, but it isn't being used. So there's no reason to keep it. Great, so we have the entities, we've enriched them, and we've used the threshold to see whether they're in use or not. Next thing would be to create the permission baseline based on usage. So part of it is already handled through the unused policy attachments. The next thing would be to create groups from your users. So part of the CIS benchmark, it's really recommended to manage all the IAM user permissions through IAM groups. That way, when an employee leaves or something like that, you can just detach it from the groups and be done with it. You don't need to go to that specific user and fix his permissions, as well as it allows giving a specific policy to a group of users at once, not just one by one. So with that command, what we want to achieve is to complete our permission baseline and to have a plausible recommendation. So let's see this command in action. The command is AIRIAM recommend groups. I'll hit it. It uses the data from the previous command. And this, as you see, it's really quickly. It creates 3 groups based on the active users, the admin group, the power user group, and if there are read-only users, it will also create a read-only group. In this case, it did not. And what it does is collect all the users which have admin access and add them to the admin group, collect all the users who have some right access to the account and add them to the power users group, and then all the users who just read stuff from the account to the read-only group. So if we mix this output with this output, the find and use and the recommend groups, we know all the changes that we need to do in the account. It's just that now we'll need to take this data, put it in a Google Sheet or put it in a doc, and go with that to the relevant stakeholders, to the relevant developers, DevOps, managers, whoever it is in your AWS setup, and get their approval. As I said before, this isn't easy. So the third command, Terraform, is the one that should help you really create a recommendation that you can talk about. Let's see that for a second. So AIRIAM Terraform is the command, and if I run it now, what it does is get all the data that was collected through AIRIAM find unused, and it's identified 53 entities in the account. Well, it's a really lightweight account for this demo. And as you'll see, it created the Terraform code and starts to import the entities to its state file. So you can start managing it today from Terraform. As you'll see, the output here says that the resource is already managed by Terraform. That's why, that means that this supports reusing existing setup. And You can run it again and again, and it doesn't mean anything will break. It will identify that it already imported the entity and be done with it. So let me cut that off real quick and run it with the flag without import. So this means it only creates Terraform code without the Terraform state file. And as you'll see, it says it successfully migrated the current IAM setup to Terraform, and it tells you exactly what it migrated. So it migrated 6 users, 4 groups, 4 roles, and 18 policies. It also migrated all of the relationships between them. That's why it was 53 entities, although 6 plus 4 plus 4 plus 18 is a lot less. If you want to see your code, well, it says that it's in the results there. So if I open results, you'll see the actual Terraform code, all the files according to the different entity types and the state file. Let's open the groups file, for example. Let me make that a bit bigger for you guys. So as you see, we have the groups and the relevant policy attachments for each group, and it's all in Terraform. It's native Terraform. You can edit it and you can do whatever you want. Let's say I don't want the S3 group. I can just delete it and we're good. So how cool is that, right? This is an exact copy of your current IAM setup in Terraform, and you can start managing it as code from this day on. So how can we leverage that to get approval from the relevant stakeholders? I think that's kind of very easy to see where this will go. Your choice of version control system, we like GitHub specifically. So I used GitHub for this. I committed the current IAM setup to a master branch, and then I ran another command. I ran the without unused. And this creates the Terraform files without the unused entities in them. So you see that it only migrated 2 users now, 2 groups, 1 roles, and 17 policies. And again, it overwrites the same files. So if I'll go to the groups, you'll see that groups Terraform, you'll see that now it has a lot less groups and a lot less policy attachments because all of those were unused. Cool, right? So what I recommend doing to handle the stakeholder approval is to commit these changes to a new branch in this IAM repository that you just opened. And then you can open a pull request of the changes you want to incur on your account. So you'll see that this is exactly what I did, right? I removed the unused. So you'll see that it marks all of these groups as to be deleted. It marks these policies to be deleted, and you can just tag the relevant stakeholders. Hey man, I want to remove this role. Can I remove or please approve, right? And if he can respond to that, he can use all the known pull request mechanisms like approving the PR or requesting changes. And that is a tool that he already uses. All DevOps, all engineers know this tool. They'll be able to use it very easily. And it will allow moving a lot faster through the approval stage. Cool. So, that covers the entire flow, right? We saw how we enrich the entities, find out if they're unused, create a permissions baseline, create the recommendations, get the approval from the relevant stakeholders, and implement the changes. How long will this flow take you? Well, if you run it from scratch and not using what I already used, enriching the entities might take a few minutes. All of this takes about the time that you saw. Maybe creating the Terraform state file will take a long while, but you can just let it run in the background and continue to the next task that you have. Come back in maybe 30 minutes, maybe 40 minutes, and you're good to go. And then the last but not least is to get approval from the relevant stakeholders. Again, this is kind of unbounded, but once you use a tool that they already know and feel very familiar with, it'll be much easier to make the changes. And implementing the changes using Terraform should take you maybe a few seconds and you're done. So that really reduces the time to right size. It's really cool. Great. So I ran AIRIAM once. I scanned. I set everything up as it should have been. What now? So scanning IAM, as we talked about before, to maintain your IAM, you'll need to scan it on a regular basis. Why? Because people make manual changes. People need stuff to work now and will worry about the repercussions later. And so you need to be able to identify the drifts and changes in your IAM setup. You need to find out if stuff is out of use, and you'll need to identify new configurations to make sure they're all in line with your policy and patterns. The second thing is to use static analysis tools to identify bad practices. And I really want to focus on that point because using Terraform can really enable you to make stuff better. So for example, two very good open source tools that will help you manage your Terraform code. The first one is Chekhov. It helps identify bad practices in general Terraform code, but also in IAM Terraform. And this tool can actually be integrated with your CI/CD pipeline to avoid the security issues before you deploy it to your AWS account. So it's really cool regardless of AIRIAM, but I think it connects really nicely with AIRIAM because let's say someone made some manual changes, AIRIAM pulls the data, and then Chekhov can identify it as, well, this policy is bad because it has, well, for example, it gives you admin access to the account. Another really cool open source tool is called Policy Sentry. It's by Salesforce, and it helps create new right-sized IAM policies. So it uses basic CRUD methodology, and it allows you to build from YAML files the policy JSON. Once you use this tool, you'll get the JSON file, you put it in your AWS account, and the next time you run AIRIAM, you'll get it in Terraform code, and you can manage it like all the rest of your IAM setup in code. Cool, right? I want to call out two other use cases that can be covered through open source. One is to really do very fine-grained right size of privileges. There are two ways of doing this: using Cloud Tracker by Duo Labs or using Aardvark plus Replicate, which are Netflix tools. Both tools, they use different methodologies, but they are based on CloudTrail data. So I just wanted to say that CloudTrail, it doesn't support, especially out of the box, all of the IAM actions and permissions. So you need to be extra careful when you use these tools, but they can give you really great insight into what exactly is in use and not in use in each one of your policies. Another really good tool is called PMapper or Principal Mapper. It's by NCC Group. And what it gives you is the ability to see all of the privilege escalations in the account. If we talked previously about the user that can assume a role, that can assume a role, and so forth. So this is an example of a graph, of a part of a graph, which is the output of PMapper. And as you can see here, we have a role, and this role can assume this role and this role and this role. Same as this user, which can assume these two roles and this role. So the privilege boundary of this user is not just the policy that it has attached. It's also the policies that are given to these three roles. And the same goes for this role. They might have very different usage. This is for EMR service role, and this is an EC2 manager user, but they can all do all the actions that are defined for these roles. Great. So I hope you enjoyed this talk. I hope you found it interesting. Feel free to reach out on Twitter or on GitHub. I'll be available, and I'm here for some Q&A. If you have any questions, I'm here. Thank you.